Don't be misled by the name. A black hole is anything but void. Instead, there is a lot of matter crammed into a little space. Imagine a star 10 times as massive as the sun being crammed into a sphere the size of New York City. As a result, there is a gravitational force that is so powerful that even light cannot escape. These bizarre objects, which are widely regarded as the most fascinating objects in space, have recently been given a fresh perspective by NASA instrumentation. Since ancient times, there has been speculation about the possibility of a vast, dense object in space from which light could not escape. Einstein's theory of general relativity, which demonstrated when a big star dies, leaves behind a small, dense remnant core, is most famous for foretelling black holes. The equations demonstrated that if the core's mass is more than roughly 3 times that of the Sun, the force of gravity will outweigh all other forces and result in the creation of a black hole. Black holes are invisible to telescopes that look for light, X-rays, or other types of electromagnetic radiation. But by observing how they affect neighboring matter, we may deduce the existence of black holes and study them. A black hole will accrete matter, or pull it inward, if it passes through a cloud of interstellar matter, for instance. A normal star may experience a similar behavior as it approaches a black hole. In this situation, when the star is being drawn toward the black hole, it may rip apart. The heated and accelerated attracting matter radiates X-rays into space as it accelerates and warms up. Recent findings provide some fascinating evidence that black holes have a profound impact on the areas around them. They release strong gamma-ray bursts, devour neighboring stars, and stimulate or hinder the birth of new stars depending on where they are located. The finish of one star is the start of a black hole. Most black holes are created from the remains of massive stars that explode in supernovae. Smaller stars eventually develop into dense neutron stars, which lack the mass necessary to confine light. Theoretically, it may be demonstrated that no force can prevent the star from collapsing under the pull of gravity if the overall mass of the star is great enough, about 3 times the mass of the Sun. However, an odd thing happens when the star disintegrates. Time on the star slows down in relation to time kept by observers far away when the star's surface approaches an idealized surface known as the event horizon. Time stops when the star's surface hits the event horizon. As a result, the star becomes a frozen collapsing entity. Stellar collisions may produce much larger black holes. SWIFT, a telescope operated by NASA, started observing gamma-ray bursts not long after its launch in December 2004. Astronomers deduced from observations made by Chandra and NASA's Hubble Space Telescope that the tremendous explosions can happen when a black hole and a neutron star meet, creating another black hole. Chandra and Hubble later acquired data from the event's afterglow. Giants and infants. Black holes' basic formation mechanism is well understood, but their apparent existence on 2 dramatically different size scales has long been a conundrum in the field of black hole science. Numerous black holes that are the remains of huge stars can be found on one end of the spectrum. These stellar mass black holes, which are scattered throughout the universe, are typically 10 to 24 times as massive as the Sun. When another star gets close enough for some of the material around it to be drawn into the black hole by its gravity and produce X-rays, as a result, astronomers can see them. However, the majority of star black holes are very hard to find. However, based on the amount of stars big enough to create such black holes, researchers believe that the Milky Way alone contains between 10 million and 1 billion such black holes. The supermassive black holes, which are millions or even billions of times as massive as the Sun, are giants at the other end of the size range. Supermassive black holes, including the Milky Way, are thought to be at the heart of almost all major galaxies. By keeping an eye on their impacts on neighboring stars and gas, astronomers can spot them. Astronomers have long held the view that there are no mid-sized black holes. But fresh proof from Chandra, XMM Newton, and Hubble supports the existence of mid-sized black holes. A chain reaction of star collisions in dense star clusters could lead to the accumulation of extremely massive stars, which would eventually collapse to generate intermediate mass black holes as one potential route for the development of supermassive black holes. The intermediate mass black holes subsequently combine to become a supermassive black hole when the star clusters fall into the galaxy's core. A black hole is not visible directly. Since light cannot escape, the color of a black hole is what gives it its name. But what we can see are the consequences of a black hole. We can observe the effects of a black hole on its environment by examining its surroundings. For instance, a star that is sufficiently close to a black hole can be observed being torn apart. There is probably a black hole in our Milky Way. The Earth is not in danger, so don't panic. Astronomers think that our Milky Way contains a large black hole that is located light years from Earth. Stellar black holes are caused by dying stars. Because a star's gravity will surpass the natural pressure it maintains to retain its shape, the demise of big stars results in black holes. A supernova is a phenomenon that occurs when the pressure from nuclear explosions causes the star's core to collapse under the weight of gravity. The star's outer layers are then ejected into space. The remaining portion of the core collapses, leaving a region that is completely dense and volumeless, a black hole. Black holes fall into three different categories. Primordial black holes are the tiniest black holes, with masses ranging from a mountain to an atom. Stellar black holes are the most frequent type of black hole and can have a mass up to 20 times greater than the Sun. The Milky Way is also covered in a variety of them. Supermassive black holes, which are more than 1,000,000 times more massive than the Sun, are the biggest black holes. Funky black holes are. Consider the scenario where someone enters a black hole and an observer sees it. Relative to the person watching, the time of the individual who fell into the black hole slows down. Einstein's theory of general relativity, which posits that time is altered by speed when traveling at extremely high speeds close to light, provides an explanation for this. Most likely, the nearest black hole is not 1,600 light years away. Thought to be 1,600 light years away, V4647 Sagittarii is much farther away than anticipated. According to current estimates, this black hole is located 20,000 light years from Earth. Wormholes may or may not exist. Since we don't understand physics very well, we don't know if this event actually occurs. However, this also means that everything is possible. Only being too close to black holes can be dangerous. A black hole is unlikely to engulf an entire universe because it is safe to watch them from a great distance, but dangerous if you come too close. Black holes weren't discovered by Einstein. Black holes were not discovered by Einstein, but their genesis is predicted by his general theory of relativity. Instead, Carl Schwarzschild was the first to demonstrate that black holes might really develop using Einstein's groundbreaking calculations. He accomplished this in 1915, the same year that Albert Einstein published his general theory of relativity. Schwarzschild's findings gave rise to the phrase Schwarzschild radius, which describes how much an object would need to be compressed in order to form a black hole. Black holes didn't have their official name until 1967, but British polymath John Michell predicted the existence of dark stars that may be so enormous or squeezed that light couldn't escape from their gravitational pull. New universes could be created by black holes. Even though the idea of black holes creating new worlds may seem absurd given our lack of certainty regarding the existence of other universes, research into this theory is still ongoing. An extremely condensed explanation of how this works is that, when you look at the calculations, our universe today has certain incredibly convenient circumstances that came together to generate life. We wouldn't be here if you even slightly altered these circumstances. It is theoretically possible that the singularity at the center of a black hole may shift these circumstances and create a new, slightly modified universe. That was for today. Thank you for staying with us. Don't forget to like our video and subscribe to our channel.